science is not about blind faith. And if you're a scientist in search of intelligent life beyond Earth, you cannot simply assume that Radio ET is on the air out there trying to reach out and touch you. So, before you go firing up the radio telescope and the multispectral scanner and go hunting for that needle of sentience in the galactic haystack, you first got to ask yourself, is there a needle? In other words, you really ought to try and figure the odds of extraterrestrial intelligence.
It seems that just about every discussion of this subject always comes back to the Drake equation. This was actually the agenda for the first scientific meeting that was held on the subject of searching for extraterrestrial intelligence in 1961, and Frank Drake was leading that discussion, and he thought of this equation to sort of organize the discussion. And all it says is that if you want to know whether there's any chance of this sort of an experiment succeeding, you need to know how many alien transmitting civilizations are out there in the galaxy right now.
We arrive at that number by making use of the information we have about the evolution of our galaxy.
And that number is clearly equal to this whole series of factors.
It's actually quite simple in its own complicated way. Our star, the birth rate of stars, gives you the size of the haystack you're searching, about 100 billion stars wide. Multiply that by the fraction of stars that you think have planets. Multiply that by the fraction of those planets that you think can support life. Multiply again by the fraction of those planets that you think may have intelligent life. Again, multiply by the fraction of those that you think might have advanced technology. And finally, multiply by the number of years that you think their technology stays on the air.
There's this product of factors, and it still uses the basis for a discussion of SETI today. We know the factors a little bit better than we did then. We know things like what fraction of stars have planets somewhat better than we used to, and we even have a better idea about, well, what fraction of good planets that might have liquid water, what fraction of those would ever cook up life? We're beginning to think that life is probably a fairly common phenomenon. What we don't know are things like, well, just because you have life, do you develop intelligent life? Maybe intelligence is very rare. Or, what fraction of those actually stay on the air for a long time with their transmitters switched to on?
After 4 decades of science, Frank Drake believes the equation lays pretty good odds in favor of success.
When we've completed this multiplication, we then in fact have this thing we were after in the first place, which is the number of civilizations. And if we put all this together, you will get 50,000 civilizations in our galaxy. A big number. And of course that's very exciting to us, and it tells us some of these numbers can be quite a bit smaller, and there's still a lot of civilizations to be found. And this is what motivates us and justifies searching for other civilizations. But it also says the search is not easy. So although there may be 50,000 of them out there to be found, it still means that only 1 in a million stars might have a detectable civilization. And furthermore, the nearest ones are still typically 1,000 light years away.
Basically, the Drake equation is on very firm ground. When you start with 100 billion stars in our galaxy, someone out there, somewhere, has got to be kicking around and evolving and developing on other planets.